Starting in number 16, you start seeing graphs that look like this. Now, this is a very different looking graph, but we can still approach it the same way. The first thing I would just want to bring to your attention is that it does tell us here what f of x actually equals. It tells us that f of x equals cosine of pi x. Now, the pi is in there, and it's actually changing the way the graph looks and behaves. But if I didn't have it in there, we actually would have a very hard time plotting it easily here with nice, pretty whole numbers. But that's something we'll get into the details about later. But for now, we can just see that cosine has this graph that looks like a wave. And of course, we're going to be asked to replicate that graph down here. In this case, we're going to be graphing f of x plus 6. And so I need to be able to pick out which graph I want to be using in order to be able to replicate that. Shouldn't be too hard to find, right? And yet if we look down here at the bottom, it looks like there's two of them that are almost exactly the same. And in fact, both of these graphs can be used for the exact same purpose. They just function ever so slightly differently. So let's take a look and see what each one of these does. This first one here is going to take your first point and put it at the top or the bottom of a wave. And then it's going to take the second point and it's going to put it at the top or the bottom of another wave. That's what those two red dots are meaning here. Let me show you what I mean. So if I actually grab that tool, I plot a point here, and then notice the 2 points that I've plotted are the top and bottom of the wave. That's what that one does. But if I now go and take a look at the other one, you notice the difference between the two pictures is that this one has one of the dots in the middle of the wave. That's actually where the first point would go. So if I plot that and then move the other dot around, notice that that first point, it's sitting right in the middle of the wave. So really it's a matter of, do you want to put your first point at the top or the bottom? Or do you want to put your first point in the middle? And it's really a personal preference kind of thing. So you can do either one. It will, in both cases, be able to give you a graph that looks like this. Now for me, what I tend to pick up on when looking at these graphs is where it starts. And by starting in this case, I think of it as where does it cross the y-axis? And in this case, it's starting right at the top. And so I'm going to choose the button down here where, and putting my first point at the top of the graph as well, because that way I can just replicate exactly what I'm seeing up there. All right, so now that I know that, I now need to come over here and deal with the fact that I'm graphing f of x plus 6. I got to remember what that plus 6 does. So the plus 6 is in with x, and therefore it moves it in the x direction. Plus always moves to the left. And so this is going to be the exact same graph as what I see up above, except shifted to the left 6. In order to do that then, I'm going to be grabbing my first point right here, just because it's a nice, easy one to grab. So I'm going to make that my first point. I just have to remember that it is shifted left 6 when I plot it there. So notice my first point, it's at the exact same height, but shifted to the left 6. I now need another point to go with that, because notice that as I'm moving this around, I'm dragging where the bottom of the wave next is. And it's the very next one. So I'm going to go up here, and remember I started with this one, so then my next point would be this right here. Technically, I could also use the one to the left, but most people's brains are going to be working going to the right, so that's what I'm going to stick with. So notice how I get there. In order to get to that point from the very first one that I plotted, I'm going to have to be going over to the right one, and then I'm going to have to go down 2. So if I now do that with my graph, I can take that second point and move it so that it has gone over to the right one and down 2. And in that way, I'm matching up with these 2 points from the original. I'm just taking each of those 2 points and moving them to the left 6. Once I've done that, then I'm done with this particular problem, because I have now replicated the same graph, just left 6. As a side note here, you may notice here that this wave and this wave look exactly the same. That can happen with these graphs, where as you move them sideways, if the wave overlaps itself, yes, it can still be the exact same graph, and there is potential for that to happen. It's actually one of the kind of cool things about these graphs. All right, let's go on to our next problem, and in this case, it's sine of pi x. Now you notice that sine looks very similar to the cosine graph that we were just dealing with. It's another wave, although it does look ever so slightly different. The big difference between them is that, remember, cosine, it crossed the y-axis at the top of the wave up here. But sine here, notice it's crossing the y-axis at 0, 0, which is the middle of the wave. And since I do like to start with the point that's right in the middle of the wave, I'm going to be using that other tool. I want to be using this button instead, because this one means that I can put my first point right in the middle, and then the second point is going to be going into the top or into the bottom from there. Now I just need to know where to put that first point. All right, so I'm going to come up here, take a look and compare, and I look to see what is happening in my function this time. In this case, it is f of x minus 2, where the minus 2 is inside the parentheses with x, which, yes, means that it's going to be moving it in the x direction. Specifically, minus moves it to the right, and so it's going to be going to the right too. So I'm going to be taking the same points as I have in the original one up here and moving them to the right too. So my first point that I like to grab is this one. And so that point is going to be moved to the right 2 as well. So I'm going to be putting my first point right there at 2, 0. Once I've done that, then I need the next point. And what that point should look like, you'll notice that as I move this around, I'm moving where the top is. Or I could move it to where the bottom is if I really wanted to be different, but I'm going to move it to where the top is, because notice it's increasing up there. Well, I'm going to have to put that in the right place. Well, if I count it up there, it looks like it reaches the top when it's only over a half, and it's up 1 from that first point. And yes, that is indeed what it's doing. And as you can see, the graph will let you lock on to that half point, so yes, you can plot it there. Once I've plotted that graph there, then that one is done. I've basically taken these 2 points and shifted them both to the right 2 in order to create my new graph. On to my next problem now. You'll see that in this case, I'm going to be dealing with sine of pi x again, and I have the graph, so this is the same basic graph as what I had last time. Let's see what we're doing to it this time. In this case, we have a plus 2 hanging on the end, which means it's going to be moved up 2. All right, so we know we're going to be moving this original graph that we have up here at the top up 2. So basically, I'm going to be trying to take that first point, and I'm going to move it up 2. And then I'm going to take that next point, and I'm also going to move it up 2. And once we've done that, then we'll have our new graph. All right, so first thing I need to do is I have to come down here and pick the right graph. This is the one that starts in the middle, and so I'm going to choose the one that lets me put my first point in the middle. And then notice my first point, instead of being at 0, 0, it's going to be at 0, 2. And the next point from there is going to be over just a half, but up 1. And you can see that the spread of the waves looks the same, the height of the waves looks the same to help you visualize and verify that yes, this does look like you did it right. And yes, this would be the correct answer. And then we could go ahead and submit that one. And now on to our final question out of this particular chunk that I'm covering in this video. Number 19 for me is cosine of pi x. And we're actually going to be graphing f of x plus 4. The plus 4 hanging on the end there means it's going to be moved up 4. And so I'm going to be taking this exact same graph that I have up here at the start and just moving it up 4. In other words, I specifically want to I'm going to grab this point as my first point, and it's going to go up 4. So notice that means it's going to be starting at 5 instead. And then the next point I'll have to plot will be this bottom point. And so then if I move that one also up 4, that means it's going to end up at 3. All right, that's my goal. First thing I need to do then is I need to grab the right graph. I am starting at the top and the bottom here, so I'm going to grab that graph. And then having done that, I can now look to see where those points go. So the first point goes up at 5, and then the next point, which is only over 1, is down 2 from there. And there we go. I now have my graph exactly the same as what was up above, except that it's been moved up 4.